In the b part, if we factor, I think a vertical asymptote, but maybe something else. How does this work out? Is that it? X plus 4 times x minus 3 in the numerator, x plus 4 times x minus 5 in the denominator. Now, the x plus 4s would divide out if we were going to evaluate this function anywhere but -4, or if we were going to evaluate the limit. We'd divide those out. However, we do have to acknowledge that the function is undefined at -4, because -4 makes the numerator 0. It also makes the denominator 0. So it'll be undefined there. When evaluating the limit of g of x as x approaches -4, because we can divide out the x plus 4s, we can actually evaluate the limit as x approaches -4 of x minus 3 over x minus 5, and it exists and equals whatever -4 minus 3 over -4 minus 5 is, evidently -7 over -9. Okay, so the point -4 7/9 is a hole in the graph. That is the point that the graph is getting really close to. When x gets really close to -4, it's just that x doesn't actually get to -4, so that point is not on the graph. It's a point of discontinuity, and it's a removable discontinuity. If we wanted to remove this discontinuity, we could do so simply by defining the function to equal 7/9 at -4. We could do something like this. We could say g of x equals x squared plus x minus 12 over x squared minus x minus 20 if x is not -4 and equals, let's see, 7/9 if x does equal -4. And that would fill in the hole, and it would remove the discontinuity. Now, as it stands, it's just an empty space. The way the function is current, we might want to change its name when we actually define it there. But as it stands, there's just an empty space there. So g has a removable discontinuity at x equals -4. What is the other discontinuity? Where is it? X equals 5. And at x equals 5, we'll talk more about infinite limits in the section 2.5. But as x gets close to -5, we could also use, positive 5. To positive 5, we can also use this expression. But in fact, it's really close to positive 5. The denominator gets really close to 0. The numerator is close to 2, but the denominator is close to 0. So we take a number that's close to 2 and divide it by a tiny, tiny, either positive or negative, depending on which side of 5 x is on. It's either going to be a great big positive number or a great big negative number. So it's going off to positive infinity or negative infinity as x gets really close to 5. So g has a vertical asymptote at x equals 5. The vertical line, x equals 5, is a vertical asymptote. So two discontinuities corresponding to the two numbers that fail to be in the domain, and those are the two different behaviors the function exhibits at those numbers.